When we set up polynomial long division, it's going to look a lot like regular old division. We are going to take our numerator, the thing being divided, and we're going to write that down. 15x squared minus x minus 2. And we're going to use that same long division operator. We're going to put 3x plus 1 on the outside. Now in this case, we don't have any missing terms, right? We have x squared, x, and 0. We'll talk about that in a second if we did have missing terms. But we are basically set up as we need to be. The way this is going to work is I ask myself, how many times does 3x go in to 15x? In other words, 3x times what is 15x squared? Well, that's going to be 5x. Notice where I put that 5x, I lined it up right above the other x term. I got 5x because 3x would go into 15x squared 5x times. Now I'm going to take that 5x and multiply times what I have out here. 5x times 3x is 15x squared. 5x times 1 is 5x. Just like with long division, we are now subtracting. All right, Jake, you're on the spot. 15x squared minus 15x squared. 0. All right, Jake remembered how to do math. All right, good. And then here's where I would mess things up as a student. We have negatives being subtracted. I have negative x minus 5x. So that is going to leave me with negative 6x. Just like we did on the long division, we are now going to bring down the next term. So this negative 2 becomes part of our next expression that we're evaluating. Again, the whole process starts again. I ask myself, how many times does 3x, no, I wanted a different color. How many times does 3x go into negative 6x? It would go in negative 2 times. That negative 2 goes up here. That negative 2 gets multiplied. And we subtract, and we have 0 remainder. For this particular problem, our solution is just 5x minus 2. There's a lot of small steps, right? There's a lot of different processes that we're using here, but the steps themselves come directly from the long division we've been doing since, 4th or 5th grade, right? It's the same process repeated. Any questions on anything we see here? Let's look at one more together. So this one, the setup is a little bit trickier. One thing that you want to get your sensors up to notice is that we are not in standard form here, right? We have a squared term, then a cubic term, then a constant term. So when we set this up, we want to write this in standard form. We're going to write this as 2x cubed minus x squared. And I am missing a term, right? So I have a squared, a cubic, and a constant. I don't have a term with an x in it. Even though it's not in the problem, I want to include it because we really use the shape and the structure of our long division problem to kind of organize our work. So we need to account for any terms that may or may not affect our answer. The other part of this is the same as always. We are going to divide this by x minus 3. So when we long divide, we're going to go through that same process we just saw on the previous problem. We ask ourselves, how many times does x go into 2x cubed? What would I have to multiply x by to get 2x cubed as a result? Nick? 2x squared. And where I want to place that 2x squared is up on top, right above the squared term. Now I multiply. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. And here's where I definitely would have messed up when I was in high school. Negative x minus negative 6x. So I end up with like negative 1 plus 6, which ends up being 5x squared. And then I'm going to bring down the next term, even though it's a strange 0x there, and the whole process starts again. So again, I ask myself, how many times does x go into 5x squared this time? What would I have to multiply x by to get 5x squared as a result? 5x. Why did you say 2? Not sure.
I don't know. I was looking at a 2x squared.
Oh, that's okay. So it's going to be 5x. Why is it going to be 5x? Because x times 5x gets us 5x squared. So now we're going to multiply 5x times x is that 5x squared, which we know. 5x times negative 3 is negative 15x. Be careful with your negative. 0 minus negative 15 is positive 15. And then we bring down the 25. And the process starts again. X times what gets us 15x? 15, right? So that 15 goes up on top. 15 times x is 15x. 15 times negative 3 is negative 45. We are subtracting. So 25 minus negative 45 is 70. Now you'll notice we don't have a place for this. That is our remainder. That's 70 all the way at the bottom there. So the way we write our answer is that we will add 70, but it is being divided by x minus 3. So right up here at the top of our page is our solution. 2x squared plus 5x plus 15 plus 70 over x minus 3. Easy enough. These can be tedious. They can be multi-step, okay? So what I'd like to do is pause here for a minute, and you guys are going to turn over to some practice. The other type of division that we're going to use here is called synthetic division. It's called synthetic, honestly, just because of the way it looks. It's a lot stranger, less intuitive, and less familiar to what we've seen. We can only use this method when we have a binomial in the form x minus a. We have just regular old x minus or plus some value. We use minus a because our a value always has the opposite sign as what we see in the parentheses. So you can see our steps here. We want to write the coefficients in this synthetic division format. What the heck does that mean? Well, what we do is we take our a value here. Our a value is going to be the opposite of this positive 2. So our a value is going to be negative 2. We are going to take that negative 2 and we're going to put that in this little box here. A little half square to help ourselves set up our synthetic division problem. Then we are going to take our coefficients, 2, 7, and 9, and list those out as well. We're going to draw an arrow and a horizontal line just like this. So this is the setup for synthetic division. I know it's foreign and strange. As class left last period, almost unanimously, everybody preferred synthetic division. So just bear with me while we kind of learn the ropes here. What we do to synthetically divide is we take this first 2 and we drop it below the line. And then we perform two operations, multiplication and addition. So I take my a value, I take my -2, and I multiply it times +2. The result is -4, which I place underneath the next term. Then I multiply -2, I add that column. 7 minus 4 is 3. Now I multiply -2 times 3, and I get -6. Then again, I add that column, 9 minus 6 is 3. Those numbers below the line are the coefficients for my solution. I like putting a little box around the last term. That is our remainder. Okay, so we've done all the math here. We just need to turn this into a solution. My biggest piece of advice is working right to left. The last term is our remainder. We're going to write this as 3 divided by x plus 2. The x plus 2 came from the original problem. It gave us our a value of -2. As we work right to left, this 3 is by itself, and this 2 is multiplied times x, because as we go right to left, we add degrees. So this term here, the 3 has degree 0, this has degree 1. If we had more terms, it would be squared, cubed, and so forth. All we have to be able to do mathematically is multiply and add. Yes?
For the A value, is it just the second, just multiply with the equation, whatever the number is, turn it to a negative?
Yes. So your a value, this quantity here, we had x plus 2, so that turned our a value to -2. If we had x minus 5, our a value would be +5. Yep. Let's look at one more together. Here is example 2. Just like with long division, I need to include any missing zeros. So if I look at this problem, I have a 4th degree polynomial. I should have 5 terms. The number of terms should always be one more than the degree. I have 1, 2, 3, 4. So I'm missing a term. Can we figure out which term we're missing? X squared. Good. So that's the way we do this. We're going to write -2. That's our a value. And then our coefficients are going to go 3, -1, 0, 5, and -1. That 0 is in the middle because we determined that the missing term was the quadratic, right? 4th degree, 3rd degree, missing 2nd degree term, 1st degree, 0 degree. So I need to account for any missing terms. But the process is the same. We bring the first term down. We multiply. -2 times 3 is -6. Then we add to get -7. We multiply. We add. We multiply. We add. We multiply. And we add. This last number here, this 45, I like to put a little box around it. That reminds me that it is a remainder. I think the hardest part about synthetic division is going from here to our solution, just because sometimes people make small mistakes. So what we're going to do to finish this problem up is work right to left. The 45 gets divided by x plus 2. The -23 remains by itself. The 14 gets multiplied times x. The -7 by x squared. And the 3 by x cubed. What we'll notice with synthetic division, the answer should always have one less degree than the polynomial we divided. I started with a 4th degree, my answer is 3rd degree. So right at the bottom of the page, there are 2 you try problems. I would like you to try them, and then we'll get into some practice for the day.
Is that the right answer for?
All right, so here you can check your work on numbers 1 and 2.